Hi, we're Josh Bronte, Ethan Delaire, and Robbie Ellis, and we're going to be talking a little bit about our modeled scenario. We have modeled our scenario off of a problem we covered in the physics lecture course. The problem involved a rocket being fired with an initial velocity horizontally at a package full of emergency supplies sitting at rest on the edge of a cliff. The rocket contained a stick attached to it, which allowed it to pierce the package, modeling an inelastic collision. The rocket package grouping underwent projectile motion, crossing over a body of water and landing in front of a person in need of rescue. The objective of our project is to model a similar scenario with a few modifications. Our objective is to provide an ingenuitive and novel way to transport a package to an individual using a rocket-like contraption. This model can be adjusted to fit varying environmental conditions, etc. In terms of the physics concepts covered, we intended to explore conservation of momentum, collisions, energy, and projectile motion. In our scenario, we have a package where we're trying to deliver that package to a person on the ground level opposite a body of water. The package is on top of a car moving at constant velocity. We get the package moving, then use a rocket with a thruster to apply a constant force. The rocket collides with the package at the instant that it's at the edge of the hill, launching the package onto the other side of the body of water. In terms of using this project, the user must adjust their constraints and presets, such as velocity, mass of the package, etc. Then the user must press the play button and the simulation will proceed to completion without additional user interference. The two main variables in this situation were the force of the thruster and the force provided by the spring. An increased force from the spring resulted in a faster moving cart, which required us to increase the thrust force on the rocket in order to reach the package before reaching the edge of the cliff. Increasing the thrust force also provided a stronger impulse to the package, which had a much more significant effect on the package's velocity than the spring. So now Ethan's going to run the simulation and then talk a little bit about various modifications.
Okay, so here we have our model. We have on the right, the little friend is stranded on the island across from the water. We have our cart, our truck with the package on it, ready to go. We have a spring next to it on the left, ready to push the cart forward. And then we have someone up on a ledge, ready to launch a rocket and launch the package across. So to start, just run it. You can see that the spring hits first and then the rocket, and just makes it across to our friend. So one of the things users can play around with to try to make it across is the mass of the package. So you click on the object, click material, and then play around with that. So let's set it to 2 kilograms. And still makes it across. Another thing we can play around with is the friction between the truck and the package. So once again, go to material, and you can increase friction. And it makes it across. All right. You can also change the velocity of the cart and package initially. So before the springs hits it, it could be going a little bit faster. So it started at 0 in the original simulation, but now we'll start it at, say, 0.5 meters per second. And it makes it across. And the last thing I'll change is the wind speed. Right now, I think it's going at a nice 20 meters per second. But if we want to just put them in a hurricane, we can do 50 meters per second. And as you can see, it doesn't work. So, yeah, The momentum and force vectors for the rocket and package are shown, demonstrating how momentum is transferred from the rocket to the package in the various simulations. There we go. Up on the left shows the momentum, its X and Y directions of the package, showing each of the collisions when in the initial increase as the motor goes, and then the spring hits, and then eventually the rocket hits. Yeah, Robbie?
All right, so before setting up our scene in Algodoo, we first made some calculations to figure out what values we should assign to each object, such as the spring constant, thrust force, and others. But when we went to implement our model, we discovered that a real simulation of these events is much more complicated than the modeled situation we used while making our calculations. For instance, when the rocket hit the package, we expected the package to only undergo linear motion, but the package began to rotate, which is something we didn't account for in our model. Also, when making our calculations, we set up the problem so that the center of mass of the package just reaches the other side. However, the package makes contact with the ground before the center of mass reaches the other side. So, not taking this into account can lead to things like the sides of the box hitting the edge of the platform, which can cause it to lose velocity and not make it over. So these complications, along with others, made us realize that many of the questions we consider in class are very idealized, that the numbers we produce or the situations we consider often won't work or won't all be observed in real life. So since the only forces being applied to the package were from the spring system and the rocket, we were able to modify both to reach a point where the package gained enough momentum to reach the other side. Some of the problems we encountered when designing our scene due to the use of Algodoo were the presence of gravity and the thruster force, which made us unable to model the situation as having conserved momentum or it being an elastic collision, since the kinetic energy of the system are constantly changing. Uh, some problems which were more due to Algodoo were also the fact that we couldn't get the rocket to stick to the package. Um, we just observed that the rocket made contact with the package for a brief period of time. So we were able to keep changing the force of the thruster to provide a large enough impulse to move the package to the end of the body of water. So that's pretty much it.
And yeah, and so when we were working on this project, we decided to share it with each other by actually posting it to Algodoo Box, so that we could download it and kind of share it with each other, because the file was too large to send. But yeah, we hope you guys enjoyed.